11-1 chemistry, and we're off. So 1, you could either have a name or you could have like the explanation of said name. Once you get your own paper back, I'll do a rewind of this and we can make sure we have everything that we want to have. But for one of the things, you could say expansion, or you could have explained what expansion means. What expansion means is it fills all of the space in which it's placed. You could have said indefinite shape, or you could have said indefinite volume, or you could have explained what that means. The book said that it means it fits in any vessel. You could have just dropped the word compressibility, or you could have explained that a large volume of gas can be fit in a pressurized tank. You could have dropped in the phrase low density, or you could have explained something like gases get measured with grams per liter, whereas solids and liquids are grams per milliliter. You could have dropped in the word mixing, but they didn't really explain mixing, but gases are capable of mixing. So there was 5 main like headers, and then they explained them all. So whether you named them or explained them, I would take that either way. Does anybody have something there you want me to analyze whether what your person said was right or wrong on what they wrote? 4 is a kinetic theory. 5 to 7 is a lot like 1 to 3. We could go just the name, or if you took the explanation instead, I would take that. There's 5 of them, you need 3. So 1 is gases are composed of molecules. If you said that most of the volume was empty space, I would take that as a synonym concept. They said there were no attractive forces of the molecules. If you just said no attractive forces, I'm fine with that for a day. They said there was constant rapid motion of molecules, so if you had constant or you had rapid, I'll take it for today, and tomorrow I'll get a little bit meaner. They talked about perfectly elastic collisions would work. If you wanted to explain that and say you don't lose any kinetic energy, I would take that. And then the last one you probably wouldn't pick to say, because it had more words, was that the average kinetic energy is proportional to the Kelvin temperature. Anybody want me to examine something 5 to 7 of what got written? Okay, 8 is ideal gases, 9 is real gases. 10, you could either say low temperature or you could say high pressure. Doesn't really matter which way you go there. Question about scoring that up? I'll get the scores once the record has cut. Homework off of this. There's one-dimensional analysis problem, so I had fibbed to you yesterday when I said there were none till the last day. They sneaked one in on me yesterday, I didn't notice. The homework we can do tonight off of this is a 1A to D, which is basically just a retread of the vocabulary we did. There's a 2A, which is a retread of the vocabulary we did. And then there's a 4 to 7. 4 is a retread of the vocabulary we just did. 5 is a retread of the vocabulary we just did. 6 is a retread of the vocabulary we just did. So there's one math problem, which is number 7. Number 7, it just is a dimensional analysis unit conversion. So just like try it, and if you can't do it, we'll deal with that tomorrow. But 7 is just try with dimensional analysis to do a conversion. Question about homework?
2 was just A, right?
2 was just A, yeah. So 1 went A to D, 2 was just A, 4, 5, 6, 7, but 7's the only one with math. Question about homework? Quiz, information, life, and what we're trying to understand, and try to put this in regular people words maybe instead of too sciencey of words from this. Well, first you need to read 11.2. So 11.2 is going to have a definition, a device, and some numbers. They're going to talk about a thing called standard pressure. Do you know anything at this point in the year about, yeah, you know some stuff about standard pressure. Okay, that's one of them. This reading is going to mention like a lot of different ways that standard pressure could get expressed. The one that we just did on the test is one of them. But there's 4 total points from the reading. 1 definition, 1 device, and then 2, you'll need to know 2 of these standard pressures, but ultimately you're going to need like 8 of them. There's a bunch of them in the reading. But 4 new points for quiz read purposes. Question about the new read? Okay, then 1 to 3 blows up into a 9-point question. So it'll ask you to name the 5 characteristics, all 5, and then to explain 4 of them. So I'll run these back through again. I had already said all of this, but we'll say it at a time that you can write. Expansion is 1. Expansion, the idea is it fills all of the space, emphasis on all, fills all of the space in which it's placed. If you had a gas in this room, it would spread out to like fill the whole room. If you don't believe me, we could take a buoy at the front, spray on a bunch of Axe body spray, and then see if somebody in the doorway eventually smells that. And the answer would be yes. Someone down the hallway will, in fact, sooner or later probably smell that, given enough time. But gases are going to fill all the space in which they're placed. 2 is indefinite shape or volume. Keyword on this is fit. Okay, so one of the keywords on expansion is fill. Keyword on this indefinite shape volume is it fits in any vessel. So whether we had a gas in this classroom or a gas we wanted to put into Melissa's giant cup, or whether we had a gas that we were going to put in a box or whatever, gases will fit in any of that, or gases would fit in any of that stuff. It doesn't care what shape you give it, it's just going to fit. Gases fit in things. So expansion, it fills. Indefinite shape or volume, it's going to fit. And when I say or, I don't mean put one, I mean put both. Put indefinite shape or volume. Put all 4 of those words. Compressibility is a single word, single point, and then the idea of that is a large volume of gas can fit into a pressurized tank. Where do you see such a thing happen in the real world with people? Where do you see a large volume of gas fitting into a pressurized tank? Scuba divers, sure. They've got that oxygen tank, they compress that oxygen, take a lot of oxygen in their tank for scuba diving. True story. Who else do you see with pressurized tanks? Asthma inhalers? Yeah, there's a lot of puffs compressed into that asthma inhaler. True story. Where else do you see that? Think birthday parties. Yeah, balloons, like helium balloon stuff. Or if you go to Party City, they probably have a thing, they blow up their balloons out of this pressurized tank of helium. But yeah, that's all examples of that. Low density is a point. The low density explanation, you're going to say it's measured with grams per liter, and you don't have to write those words, you could write this. It's measured with grams per liter. Instead of solids and liquids, get measured with grams per milliliter. A liter. Like, about how big is a liter? Can you give some context to that? Yeah, that's probably a liter right there. You probably all have seen 2-liter drinks, 2 liters of Coke or whatever. Cut that in half, that's a liter. So a gram, about how much is a gram of mass? You think of anything that weighs about a gram? Some grams.
It's chicken.
Yeah, like a paperclip size thing. A paperclip's probably about a gram, or like a pill you swallow. Some pill, decent sized pill is probably about a gram. So if you're trying to measure gases, usually it's about a liter's worth of space to get a gram's worth of mass. It's not very dense. A milliliter? How much would a milliliter be?
Small.
Small, like a drip. If you were a little kid taking medicines out of the cup, like the lowest line on a little kid medicine cup's probably like 5 milliliters. 5 or 10 would be your lowest line. So if you've got solids or liquids, a gram might only take up like a drip's worth of space, whereas gases, a gram might take up a big giant bottle's worth of space. So low density. And then mixing, just say mixing. You don't have to say that. When we get to the test, I'll give you a bonus point for this fact. So if you want to jot this down, bonus point fact on the test is about natural gas, and this has to do with mixing, but this isn't super important. But natural gas gets mixed with the chemical formula C2H6S, which is a smelly thing. Why do they do that? So that you can smell leaks, because natural gas on its own is odorless. So like when the recent thing they had in Plum where that house exploded, and they're like, they wonder if it's natural gas. If it was natural gas from a well, they would have never smelled that. If it was natural gas from a pipe, they should have smelled that. But natural gas on its own, coming out of the well, out of the mines, out of wherever it comes out of, there is no smell for natural gas. So natural gas gets mixed with this C2H6S thing to reveal leaks, so people can smell it and not like blow things up, because that's highly explosive. Question about a retread of that 5, either what I'm hunting for you to say, or just explain in human terms what any of those words mean again.
Wait, what was the number thing, letter thing? C2H what?
C2H6S. It's probably the sulfur that smells, because sulfur's pretty smelly. Something. Kinetic theory. I'll be hunting 3 things from the kinetic theory, and they're all here, so you could just underline them on the quiz. Maybe it's the easiest way to go. Heat and motion are related is a key idea. The particles of all matter are in motion to some degree. And then the third is that heat is an indication of the motion. In other words, we know there's motion because we can sense the heat. Heat, like motion is the cause, heat is the effect. Like you see the heat because the motion caused it, and the heat proves that the motion was there. Gases move a lot better than solids and liquids do, but everything's in motion to some degree. If somebody said, that's a lie, your table's not moving, well, I'm not lying, I'm telling the truth. I'm not talking about my table moving, but it is. How is my table moving? But people would say, that table's not moving, you're crazy.
Earth's moving.
How do we know?
Earth's moving?
Well, other than Earth spin and all that, in terms of kinetic theory stuff.
Because of molecules.
Molecules. We're talking about molecules. So you can't see the molecules of the table, but if we bust out the super microscope and look at the molecules of the table, they are in motion. Are they in motion the way the gases are in motion? No. It's easy to show that gas is in motion. Gas in motion, that's not hard. You feel that all day long, stuff happening to you. But the particles of the table are also in motion, but not to the degree the gases are. It's like just a little bit of vibration. Easy or hard to see that liquids are in motion?
Easy.
Pretty easy, just you can see it, stuff moving around your bottles. It's not hard to see that that's in motion, but the table, the molecules are in motion. 5 to 7 blows up. Instead of a 3-point question, that's now a 7-point question. So it'll say, name the 5 assumptions and explain 2. Key word on this is going to be molecules. I'm going to say molecules like at least 3 times. So 1 is gas is composed of molecules. Follow-up explanation for that one is most of the volume is empty space. So if you're wondering, how is this, I'm saying the Axe body spray would expand and fill the whole room. Well, how is there space for that? The answer is most of the volume of gas in this room is empty space. There's plenty of space for the Axe body spray to go fill the room. 2, there's no attractive forces of the molecules. Solids, liquids, gas is very different. My table, the molecules have an attraction that is very strong. Liquid, there's an attraction that's kind of like medium. The liquid isn't attracted like the table is. But gases, they just kind of do what they want. Constant rapid motion of molecules. I think the book made an analogy. It's kind of like envision bumper cars, which now at Kennywood we've got them as the potato patch fried motif. If you didn't see that news break, the cars all dressed up like French fries. With the bumper cars, it's no longer the Grand Prix bumper cars. It's now like the potato patch, something or other bumper cars, and the cars all look like little ketchup containers, or French fry containers with like ketchup stuff, yeah. But the gas molecules, they're in constant rapid motion, just clonking into each other all the time. So constant rapid motion of molecules, that was the third one in a row that I said molecules. Fourth one, we're going to say there's perfectly elastic collisions. And then we're going to follow that up with the second explanation we were hunting, which is there's no kinetic energy lost. What was kinetic energy from your earlier experiences?
Motion.
Energy of motion. So most collisions are inelastic. Like if you go out today and you're on the bus on the way home and Ingrid rams the bus into a car, that did happen one time. Both of those vehicles are going to end up losing motion. They're both going to slow down. There's going to be kinetic energy lost in that kind of a collision. An inelastic collision, anybody remember something that was close-ish to inelastic, but not quite perfect, but better than a bus hitting a car on the way home?
I body slammed Matt Penny with a yoga ball all the time.
That would be an inelastic collision, because that ball would slow down.
The pool game.
Yeah, like pool, billiards, whatever you call that. You know, when the billiard ball hits the other billiard ball, they somewhat slow down, but there's still a good bit of motion off that. Not quite like a car hitting a
Oh wait,
building
a
or
hockey
something.
puck.
Hockey puck, what's it called? Like table hockey? Is it called table
Air
hockey?
hockey?
Air hockey. That's somewhat inelastic. There's not quite the same sort of slowdown. None of that's perfect, but that's decent. But these molecules, they have perfectly elastic collisions. They're clonking into each other and they're not slowing down at all. And then the fifth one is that average kinetic energy is proportional to Kelvin temperature. What this means is the more temperature you give it, the more motion you're going to get, the more clonking around off of each other you're going to have. But average kinetic energy proportional to Kelvin temperature. 8, you continue to fill in the blank with ideal gases. And I'll break the news to you, there is no such thing in the real world as an ideal gas. There are no gases that act perfectly like ideal gases. Nitrogen, oxygen, hydrogen, the noble gases, they're close. Air is close. CO2 is close. But none of those are perfect ideal gases. They're in the neighborhood, but not so great. What do I mean by noble gases? What were those? Very right side of the table. Anybody know any noble gases? Neon was one. Xenon's in there. Radon. Krypton, not kryptonite. Argon. Helium, arguably, sort of as a special case. They're all over there. 9, you'll still continue to fill in the blank for real gases. 10 will become a 2-point question. You'll say both low temperature and high pressure. Why does a gas at low temperature get less gassy? What does a gas at low temperature kind of want to do? Yeah, become a liquid. So if you go low temperature, gases get less gassy. If you go high pressure, it does the same thing. If the gases in those scuba tanks, they're less gassy than gas in our air. Like the oxygen you breathe acts differently than the oxygen in that high pressure tank. They just aren't quite the same. You get it in the pressurized tank, it gets a little bit more liquid, solidy in its behaviors. That's our words and explanations of the day. So again, the quiz will total now 27. So that 1 to 3 zone became a 9-point zone. 4 became a 3-point zone. 5 to 7 became a 7-point zone. Kept 8, kept 9. 10 became a 2-point zone. Lots of information there. But you'll get a rehearsal if you do the homework. The homework is going to have you write out like a lot of the stuff we just said as a reinforcement technique. Anything I can do for you? Yes, sir?
Can you repeat 10?
10, you're going to say low temperature and high pressure. And I wonder if I just stood too close to that camera and recorded the whole thing with my head cut off.
A little bit.
A little bit. The information's there, the audio matters, the video's not as important as the audio.
Yeah, you got about up to your eyes, I think.
That's the best part of me. My hair's getting a little gray, just cut that out. Anything, rerun anything?